In the deep shadows of classified airfields and beyond the veil of public knowledge, a secret world exists where the laws of physics are constantly tested and redefined. This is the realm of experimental military aircraft, machines that embody the cutting edge of technology, speed, stealth, and imagination. Their stories, largely untold, weave together the brilliance of engineers, the audacity of test pilots, and the relentless pursuit of air superiority by the world's most powerful nations. The concept of experimental military aircraft isn't new. Since the dawn of aviation, militaries have pushed boundaries to gain an edge in the skies. During World War II, German scientists introduced the Messerschmitt Me 262, the world's first operational jet-powered fighter. Though it came too late to change the war's outcome, its mere existence sparked a global realization that jet propulsion was the future. In the wake of the war, captured designs and scientists were swiftly absorbed into US and Soviet programs. This ushered in a Cold War arms race that would see the sky become a stage for the most audacious innovations in human history. At the heart of America's experimental efforts stands Area 51, a site shrouded in secrecy and myth. Here, projects like the U-2 and State Route 71 Blackbird took flight. The SR-71, a marvel of aerospace engineering, could fly at over 3 times the speed of sound and at altitudes exceeding 85,000 feet. It was virtually untouchable, outrunning enemy missiles with sheer velocity. Developed under the aegis of Lockheed's Skunk Works, the State Route 71 wasn't just an aircraft, it was a symbol of what was possible when imagination met vast budgets and skilled hands. Experimental aircraft like the X-15 took things even further. Piloted by astronauts in pressure suits, this rocket-powered plane soared to the edge of space, reaching speeds of Mach 6.7. The data collected from its flights fed directly into NASA's early space programs, proving that the line between aircraft and spacecraft was thinner than previously imagined. Though it never became a combat aircraft, its legacy remains in the knowledge it provided about extreme speed, heat resistance, and high-altitude control. The Cold War also saw the development of the Soviet Union's own experimental aircraft. The MiG Bureau, in response to American advancements, rolled out prototypes such as the MiG-25 Foxbat, designed specifically to intercept high-speed threats like the State Route 71. Though it sacrificed maneuverability for speed and altitude, the MiG-25 was a striking example of experimental design with a singular mission in mind. In later decades, stealth became the new frontier. The American F-117 Nighthawk, developed in total secrecy, demonstrated that aircraft could be nearly invisible to radar. Its odd, faceted shape was dictated by the limitations of computer modeling at the time, yet it proved devastatingly effective during conflicts in the Middle East. Following the F-117, the B-2 Spirit bomber took stealth to new heights. With its flying wing design and radar-absorbent materials, it could penetrate the most heavily defended airspace undetected. Both aircraft were part of a broader experimental trajectory that sought not just to evade detection but to dominate the electronic spectrum of warfare. The 21st century introduced new challenges and opportunities. Unmanned experimental aircraft, such as the X-47B and the RQ-170 Sentinel, removed the human from the cockpit, allowing for riskier maneuvers and longer endurance. These drones could loiter over targets for hours, operate in denied airspace, and gather intelligence with unprecedented precision. Their development signaled a shift in how military strategists viewed air power, not just as a tool for dominance but as a platform for surveillance, electronic warfare, and cyber capabilities. More recently, hypersonic flight has emerged as the latest focus. Aircraft that can travel at speeds above Mach 5 are no longer science fiction. The U.S. has tested craft like the X-51 Waverider, a scramjet-powered vehicle capable of stunning speeds. China and Russia are also deeply invested in hypersonic technologies, suggesting a new era where time-sensitive targets can be struck from vast distances in mere minutes. These vehicles face enormous technical challenges, from materials that can withstand thousands of degrees of heat to navigation systems that remain stable at the edge of space. But their promise is undeniable. Speed so great that defense becomes almost impossible. Experimental aircraft are not only about weaponry. They are laboratories for flight control systems, artificial intelligence, new propulsion methods, and sustainable fuel technologies. The lessons learned from military prototypes often find their way into civilian aviation. Innovations in aerodynamics, fly-by-wire systems, and composite materials have roots in military experiments decades earlier. These aircraft are risky investments, many never go beyond the prototype phase. Others are cancelled due to cost, politics, or shifting strategic priorities. But even the failed ones contribute to a collective body of knowledge that shapes future designs. Every experimental military aircraft is a leap into the unknown. They are expensive, controversial, and dangerous. Test pilots often risk their lives to understand the limits of what these machines can do. Yet their courage and the vision of the designers who build these aircraft define the cutting edge of human innovation. In a world where air superiority remains a cornerstone of military power, experimental aircraft are more than machines. They are the vanguard of possibility, each one a glimpse into the future of warfare and flight. As we peer further into that future, the skies will continue to whisper of strange shapes, impossible speeds, and the relentless human desire to fly faster, higher, and smarter than ever before.